This is problem 15 of the Unit 3 test. This problem, the context of this problem is we're looking at the tire tread depth and trying to predict the amount of tread depth based on the miles driven. And we're given an r² value of 7.4. Okay, so I'm not sure if I can really draw a tire properly, but if you looked at your tires, you could see there's a pattern on your tires, and the depth when they wear down, the tread depth goes close to 0, and then that's when you have to replace your tire. Okay, so anyway, they say use the model. So you've already been given the model and you've been given the scatter plot. This is very typical of what's going to happen on the AP test, because we don't want to spend a lot of time having you draw this with a ruler or whatever. Okay, so we're going to do our thinking given this information. So use the model to sketch the line of best fit. So surprisingly, I should have gone over this more in class, but all you need is 2 points. So you need to calculate 2 points. So you just plug in 2 values, and what you need to do is don't plug in 0. Some people use 36, but there's a break here. 0's way over here somewhere, and so you don't want to use 0 or the y-intercept for a point. So let's plug in 30. Okay, and I get approximately 18 millimeters. And then if I do it again, I get, if I plug in, let's plug in 45. So I got some range. I get approximately 9 millimeters. Okay, so at 30, it's 18, it would be right about here. And for 45, 9's right about here. So kind of where we'd expect them to be. Let's see if I can make this look reasonably linear. Okay, so there's my line. I should use a ruler. Now, one of the things that you don't want to do is, I don't believe I took points off, but you really shouldn't draw the line through like that, because that would suggest that the y-intercept is 26, and it's not. It's 36. So don't do that. Okay, but that's all you have to do is use the model, find 2 points, draw a line through it. Okay, so what's the explanatory variable? So hopefully you remember that that's the same as the predictor variable. They're the same thing. So that would be miles. We're going to use miles to explain tread depth, and it's miles in thousands. Okay, now what's the correlation? Well, we're given r² of 0.72. So that comes out to be 0.86. So now the question is, should it be positive or negative? Well, the slope is negative. So it would be negative 0.86. So remember that r² tells us the strength and the direction. Most people only remember the strength, so be careful. Think about the model. Okay, so describe the association. So you could say, you got to write this out based on the scatter plot. We see, and you got to do 4 things here. We see a moderately strong, and if you said strong, that would be okay. I'm not going to be too picky about that, but a moderately strong to strong negative, you need to say direction, And then tell me if you think it's linear or not. Linear association. Okay, now don't stop there. Between miles driven and tread depth. Tire tread depth. Okay, you got to write that out. You got to do 4 things. You got to talk about how strong it is, the direction, whether or not it's linear, and add context. Okay, explain in the context what's the slope. So if you put a 1 under it, the slope is 0.6, right? 0.6, is that right? Yep. Okay, so now that 1 is misleading. Some people said for every 1 mile the tread depth decreases. Well, that's kind of silly, because if you drove 100 miles or so, your tires would be bald. So you need to think through it just a little bit. But so a more useful thing to do is multiply it by 1,000, because that's really what the 1 means, is 1,000. And what you get is, what do we get? Oh, you don't multiply this by 1,000. My bad. I'm thinking of something else. Here's what we do. The 1 represents 1,000 miles. So we need to put 1,000 right there. Okay? So then you could say for every 1,000 miles driven, the model predicts a decrease in tread depth of 0.6 millimeters. Okay, sorry about that. Just had to go a little bit slow, and my pen was acting out. Okay, explain in context what's the y-intercept mean. So some people did point out that we don't have points close to 0. If 0 is, I don't know, way out here somewhere, we don't have points way out here. That's true, but you could still say what the y-intercept means. What it means is when, see, where's our model? When the miles driven are 0, we would expect the tires to have a tread depth of 36 millimeters. So explain what the y-intercept means. So it means new tire tread depth so according to the model, new tires are expected to have 36 millimeters of tread depth. Sorry about that. This pen is acting out on me. So some people said when the cab is new, when there's a new cab. So be careful there. They got a little mixed up. It's really just about the tire. Okay, so what does r squared mean? So r squared is 0.72, if I recall. Okay, oh, 74. So 74% of the variability in tire tread depth is accounted for by the variability in miles driven. They didn't really ask you to evaluate it. Okay, it's a reasonably good model. 26% is still unaccounted for. And that probably has to do with things like driving style, how you drive the car, and where you drive the car, what kind of road conditions, because that's going to impact the wear of the tire. Okay, in the context of this subject, what does a negative residual mean? So if we think about it, kind of draw this out, we have a negative linear relationship. So the line is y hat, so residual is y minus y hat. So if we just take a point right here, negative means that y hat is bigger than y. So the model over predicts the tread depth. Okay, so I might have given extra credit if you would have said that the tires are wearing out faster than expected, according to the model. Okay, that's that.